So here, this video, we're just going to take a look at trying to get a sense of the difference between how the 1 over x function converges to 0. So here's our 1 over x function. So x equals 1. Okay. X equals 2 is 1/2. 3 is 1/3, 1/4, 1/5, 1/6, etc. So it kind of progresses to 0 like this. And again, as the limit as x goes to infinity, this is just going to go to 0. Okay, but we want to compare. This is our boundary function. So this one does not go to 0 fast enough to be able to converge. So why do the other ones converge? So let's take a look at the Basel series, or this is really just a P series when P is bigger than 1. And what happens when we take a look at that is, notice that this Basel series, or the P series when x equals 2, or P equals 2, this is going down. So notice how quickly that this is converging to 0 compared to the harmonic series. It goes to 0 very, very quickly, where this one's kind of taking its time to get down there. So this is why this one converges compared to the harmonic series, which doesn't converge. So if we take a look at another P series, we can take a look at the 1 over square root. So when P is less than 1, okay, and we can see that, yeah, this one takes even longer to get down to 0. Okay, so this one definitely is not going to converge. So if we compare things to this, this is our boundary sequence. It doesn't go down. It goes down to 0, but not very quickly. It doesn't go down quickly enough. This one goes down even less quickly. It's taking its time. So it's having large values for each sequence. So when we add up those infinite sequences, we're definitely not going to get to any finite sum. Whereas this one here, the purple one, is our P equals 2, or our P series when P equals 2. So this is the Basel series, and it does go down much, much quicker. Okay, so that's, if we can kind of see visually why one might converge. Okay, one series might converge versus another. So I'm just going to turn these ones off for a sec. And the geometric series, this is one we've already established. This one always converges. Okay? It doesn't matter if your base is 1/2 or base is like 0.9, is even close to 1. As long as the base is less than 0, the infinite series always converges. And notice that how quickly this one converges to 0. So even in this frame, this one's not even getting close to 0. Even this frame that we've done, there's very little height value at n equals 10, even just in this frame. So this one converges very quickly. And even compared to our Basel series, which we know converges, this one converges. The black one is our infinite geometric series. It's quite a bit lower. If we scale that in, if we zoom in even, okay, if we zoom in, that's quite a bit lower than even our Basel series. And as we go out to infinity, this infinite series, the black one, converges much, much quicker than any of the P series do.